Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem search in a 2D matrix. So the problem says you are given an m cross n integer matrix with the following two properties. Each row is sorted in non-decreasing order, and the first integer of each row is greater than the last integer of the previous row. Given an integer target, return true if target is in the matrix or false otherwise. You must write a solution of big of log m cross n time complexity. Alright, so the problem says that in the example one we can see that we are given a matrix, and from the first constraint each row is in sorted non-decreasing order. So 1 3 5 7, we can see that each row here is sorted, and the first integer of each row is greater than the last integer. The first integer of each row, let's say here 10, is greater than the last integer of the previous row 7. So basically it is saying that the whole array is matrix is sorted. Whole matrix is sorted. 1 3 5 7 10. Let me draw it also. We can see the whole matrix is sorted. Alright, now we are given a integer target, and we need to state that if the target is present in the matrix or not. So it's simple, we just can iterate to the whole matrix and check whether the target is present or not. So here matrix is given and target is 3, so we can check while going to each and every matrix and check whether 3 is present or not. Yes, 3 is present, so we can say yes, it's present, otherwise not. So similarly in the example 2 also, but this will take big of n square, not n square, n cross m time complexity, because the size of matrix is big O of m cross n, and we are asked for big O of log of m cross n. So how we can relate this with big O of log m cross n? We know we in the normal array we apply binary search when we have to find any element. So suppose imaginary hypothetically, if we flatten this matrix anyhow hypothetically, so it will look like 1 3 5 7 10 11 16 20 23 30 34 and 60. So if this 2D matrix was an array, a 1D array, alright, so what can be the start? Start could be 0, this one, and ending could be obviously total, there are total m cross n elements, so ending index would be m cross n minus 1. And if this hypothetically was an 1D array, so we can apply binary search directly here, and we can solve this in big O of log m cross n, that's asked. Now how can we hypothetically flatten this matrix? We don't need to flatten this matrix in reality, but what we do while applying binary search, first we find mid used to be the mid of start and end, that is start plus end by 2. All right, so let's say mid is what will be the mid here? M cross n, let's say any hypothetically element mid, we find mid. All right, so mid would be any index, let's say here. Now here mid actually is m cross n is 4 3 cross 4, so this index is this end is 11, and this start is 1. Let me mark these indexes also. Start is 0. Start is 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 11 indexes are marked. Now the mid in this case, in the first iteration of the binary search, will be start plus n by 2. This is 0 plus 11 by 2, and this will be 5. So the index number 5, yes, this will be our mid. Now we will compare this mid with our target. If it is equal to target, we will return yes. If it's less than the target, we will say that if our target is less, we will say that go and check in before 11, and if it's greater than 11, we will say go ahead and check there if the target is present or not. So but the problem is, this was easy for a single, for a 1D array. We know mid is just start plus end by 2, and this index came out to be 5. But in this case, this 11, this is the mid here also of this 2D matrix. But here it is, if I mark the indexes 0, 1, 2 and 0, 1, 2, 3, here it is 1, 2. 11 lies here at matrix of 1, 2. Here we need I and j also, and here we just do start plus n by 2 and we get the mid index, and just we say array of mid is our mid element. But here we need I and j. So how can we calculate I and j? So if we can calculate here the mid, we can, there is a formula that can give us I and j directly. So the formula is just, the I will be the mid divided by the column, and j is mid modulo column. Alright, there is a proof also. The proof is just very normal. You can check on internet also. If you will ask, I will give the proof also. The proof is very simple and short. You can simply Google it also. Alright, so what I told you, any index here, let's say index this, let's take this element 23. Here this 23 comes at 8th index, and here this 23 comes at 2, 0 index. So if we know where this index is 8 in the 1D matrix, the index is 8, so we can easily find out the index of 23 in the 2D matrix by calculating I and j, obviously. So I will be the index. I should write here index in place of mid, but I was just explaining mid that time, that's why I wrote mid. So in this case, the for 23 I will be 8 by total number of columns. Total number of columns will be here, we know that 4 columns are there, so 8 by 4, and j will be 8 modulo 4. So 8 by 4 is 2, and 8 modulo 4 is 0. So I is 2, j is 0. So 2, 0. We can say matrix of I, j in this case is matrix of 2, 0, that is 23. So if I tell you in short, we will just, if we have to find any element, in the matrix, we can just imaginary flatten it, and we can just apply the simple binary search only. But in that case, but in 2D array case, the mid element we will easily calculate start plus n by 2. But for checking the mid element in the 2D matrix, we have to calculate I and j. So those I and j will be nothing but any index. I should write here index in the 1D matrix divided by the total number of columns, and index in the 1D matrix modulo total number of columns. So this is the main formula. How can we in a any element in a 1D, any index, I would say any index number in the 1D matrix, how from any index in the 1D matrix, how can we find the index in the 2D matrix? We have to find I comma j, and those I comma j will be id index divided by number of columns, and j will be index modulo number of columns. So this is only the formula. You can check the proofs also. So let me code it now. So first of all, I would like to declare the size m is equals to matrix dot size, and n is the number of columns. Alright, now as we do in binary search, simple binary search, start will be 0 in this case, and end will be m cross n minus 1, the last index. And simply as we do in binary search, we will say while start is less than equal to end, we used to calculate their mid, and mid will be also simply here start plus end by 2, or there is this is another formula for calculating mid, and minus start by 2. This just ensures the edge cases of the integer range. And then what we check, if target is equals to, in a 1D matrix we used to check if target is equals to array of mid, but in this case we have matrix, so we have to definitely find out, we cannot say matrix of mid, we have to find out I and j. So I would say I will be nothing but index, that is mid, divided by the number of columns is n, and j is nothing but mid modulo n. Now if target is equals to matrix of ij, then I will simply say return true, yes it's present. In the else if case, we can just say if the target is what if the target is greater than matrix of ij, it means the target is ahead of the element which we are standing at. So we will just say that our new starting will be mid plus 1, and in this case target will be behind the mid, so we will just update our ending will be mid minus 1. Alright, and if nothing returns true, we will say that element is not present and we will return false. So if I run the sample test cases, now yes, spelling is wrong somewhere. Matrix, it's matrix. Now if I run the sample test cases, now if I submit it and check if we are able to pass all the test cases or not. So yes, we have solved this problem successfully now, and yes, we have just used a simple binary search only, but this binary search is on 2D matrix. So we have learned that how we can apply binary search on 2D matrix. And yes, the time complexity is also, we all know binary search time complexity is just big O of log of n. So here n is total number of elements in the array, that is m cross n, and space complexity we haven't taken any space, so we can say space complexity is just big of 1. All right, so this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.